Yeah, I just wanted to show you what I was up to. I got these parts that Vinny was doing, and he didn't have good luck with them. He set it up like this. He milled the angle, then he milled that shape with this one part being down, this being up. He milled that shape, then he put that shape in a set of soft jaws, and it wouldn't match up. You know, no matter what he did, he couldn't get it to match up. So that's kind of expected. Never expected that to work. But so what I did is I took these parts. This one I can't do anything with because I can't hold it. But these here, I put them in a vise with the flat side to the back, and I drilled a 1/4 hole and put two 1/4 holes in here with a 1/4 end mill for a dowel pin. And I did that to these. Now what I'm going to try to do is I made up this was a piece of flat stock, and I drilled it 265 and put two 1/4 holes in there for dowel pins, these dowel pins. And I cut the shank on the bandsaw. And then I put it on a 45 and cut that. Try to make it round. So I'm going to stick it in the lathe, stick it in the forward jaw, then indicate the shank concentric and parallel. Try to line this up, then turn this to a 1-inch diameter, and put a dowel pin hole in that, because I have a dowel pin hole in my indexer, and that acts as a anti-rotation. So I'm going to turn that round, then come back and put in a collet chuck, come back and take a little skim cut on this face to make sure that this and this are parallel with each other. Well, square and parallel, and it doesn't have to be concentric, but we'll get it the best we can. Then we're going to try to load these parts in there. Now these parts are 4 inches wide. I don't think we'll have any trouble. So what I'm going to do is this is the shape we need. So I'm going to stand that up in the bandsaw and cut this excess material off here. There's no reason why I should spend the time to mill that off. I just cut it in the bandsaw, get it close, and then set this up. And then I'm going to have to go up. I'm going to have to take a little cut on these angles, because there's a radius that goes on here, and I got to make sure that this angle is, you know, I take a cut on one end, and if it's hitting air on the other end, it doesn't do me any good. But we can take it down a little bit narrower than what the drawing calls for. But it's just a matter of you know, making sure that this waviness looks the same on both sides. The actual width of the part, we got a little bit we can play with. Yeah, there's a radius that goes on here. He tried to put that on and didn't do a very good job. But see what we can do. Now this other part, I took a couple days off, actually 3 or 4 days, and we had these parts that getting ready to run. What happened was Vinny started this job when I was gone, which is no big deal. But you see these marks that are in here. That mark right there, and right there, and right there, and right there, right there. What happened was that you had this set in the fixture, then there's it's an arbor. Then there's a nut that goes on the end, and I think he forgot to tighten the nut. So when he brought his end mill down here to do this groove, the part spun on him. And the thing is that with this shape, you can't clean it up because it's too much to clean up. So actually, when you run these parts, you know, they're sitting horizontal, and then you run an end mill or a ball end mill across here. And the thing with a ball end mill is that, I mean, it's nice, but it doesn't like to cut on the end, and it always leaves a ragged surface because there's nowhere for the chips to go. So what I usually do is, if I gotta do something like this, and this is my end mill, I'll try to turn my end mill on an angle, come across, so you're not cutting on the very end of the end mill. You're cutting somewhere on the ball of the end mill. But that works out real well. But then again, you got, you know, it's not easy to measure the part and everything, and so that's another issue. So what I did with this part, well, with this, I've been, for the future, now there's I think there's 10 of these that he did, 10 or 11, this is number 12, and we got to do some more later on. But what I did was I made this piece here. Now this is off of my 3D printer, and what it's going to do is it's going to fit, this part fits in there, and it gets bolted to the table. So you can come down with an end mill and just either come straight down with a flat end mill or come in from the side. And then you're using the side of the end mill to cut that groove. Well, it's not really a groove, it's a diameter. But then you don't have to use a ball end mill, and it's a lot faster. So I made that. And you can make it in Fusion 360, but I don't know how to use Fusion 360. I used SolidWorks. But you make this part, and then you have this model. Now you insert it into that part and use the cavity command. It's like mold making. It's like a bowling operation where you take this part and you say, I want to subtract it from this part while it's inside of it, and it'll give you that shape inside this part.